Right, so this one, you have a student standing on a scale in an elevator at rest. So initially the scale is going to read 840 newtons, and then the elevator goes up. So then the scale reading increases to 945. Then it goes back down to 840 as it's moving for 10 seconds, and then when it slows down as it gets to the top floor, the reading will drop down to 735 newtons. So you're supposed to answer, why does the scale reading change? To think about in the situation, what every instance would look like. There's a bunch of different free body diagrams that show up in this situation. So the first thing, when you're standing on a scale in an elevator at rest, you have a gravitational force down and a normal force up that are going to be equal and opposite, meaning that the weight at that time is directly equal to the normal force in that period of time. The secondary period of time is when it starts to rise. So as the elevator rises, it has an acceleration upward. It has to, because it can't just start spontaneously moving at a constant speed. So that little instant of acceleration is causing the normal force reading to be greater, which means, and this is where it gets a little confusing, the force of motion, while it's accelerating upward, adds to the gravitational value. And that seems incorrect. But what happens when you are just standing is that everything's constant. As you move up, you technically are being pushed down, which means the scale reading reads a larger value. Then the third part, it returns to 840 for 10 seconds. That's the period of time when it's moving up at a constant speed. So that 840 stays the whole time while it's moving constant speed. So again, normal and gravity are equal. So the diagrams for the first period and the third period look exactly the same. So they're hard to tell apart unless you know what's happening. And the last diagram, sorry about that, scale reading is 735 while it's coming to a stop. So it's still moving forward, but it's slowing down, which means that it has an acceleration opposite its motion, which means the acceleration actually takes away from the scale reading, so you feel lighter when it comes to a stop, which again seems really counterintuitive and confusing, but that's it. So as the acceleration is changing, that's when you'll experience either the greatest amount of acceleration and force or the least amount, depending on the direction on which it's speeding up or slowing down. So really, think about it realistically. As you are starting the elevator, your knees kind of buckle a little bit, which pushes you down, and then when the elevator starts to move down, you feel lighter. When the elevator starts to slow down, you also feel lighter.